Hello, beautiful people, and welcome. In this video, we are going to start our conversation about polynomial expressions. As always, if I make a mistake, I am human. Please let me know if and where a mistake occurs so that way I may learn from it. Let's start with the definition of a monomial. So it is a number, a variable, or a product or a product of numbers. So if we're talking about a variable, it has to be a whole number exponent, no variables in the denominator. And just a side note here, if you have a negative exponent, it means the base and the exponent in the denominator. So let's do a quick example of that. So it cannot have any variables in the denominator. For example, let's do 0.7 x negative 2. So that would mean that this x belongs in the denominator because the exponent is negative. So this in fact means 0.7 times 1 over x squared. And because that variable now belongs in the denominator, this here is actually not a monomial. So what's an example of an actual monomial? So an example of that could be something with a positive exponent. So let's do like a negative 4xy. Notice the exponent on the variable is positive. It is a positive 1. Let's do another one. It could be something like 0.25 x cubed. 3 is positive in the exponent. It could also be something like xy divided by 4. Now, 4 is in the denominator. However, it is not a variable. It's not a letter. Therefore, it is allowed. What it is not allowed is having a letter in the denominator. That's not allowed. Now let's go ahead and continue our conversation with a polynomial. Now poly means many, so therefore it is a sum, and I'm going to put sum in quotations, of monomials. So basically what that means is taking a term is separated by a plus or minus, so it's separated by plus. Technically, it's separated by plus, but you want to always note this section here. If you have a minus, it's technically adding a negative. So my personal definition is separated by plus and minuses. The official definition says it has to be a plus, but you can always add a negative. A binomial, let's shift this a little bit more. A binomial has two terms. So not many, just two. And those two are separated by a plus or adding a negative, so plus or a minus. So let's do an example of a polynomial. And a polynomial could be, for example, something like 3x squared y squared plus 3xy squared plus 5xy. There's no variables in the denominator. We have one term, two terms, three terms because they are separated by pluses or minuses. A binomial only has two terms. So for example, a binomial could be something like negative 2y cubed minus 8y squared. Even though this is a minus here, so we have one term, two terms. So even though we have a minus there, that's okay because you can rewrite this as adding a negative. So that's allowed. All right, let's go ahead and talk about the degree of the polynomial. A degree of the polynomial is the greatest value among the sums of the exponents on the variables in each term. And I want to highlight this, in each term. So basically what you're going to do is you're going to evaluate the exponents in each term. And what the degree of the polynomial is, it's that greatest value among all of them. Even though each term will have its own greatest exponent, we want the biggest one for all of them at the end. All right, let's go ahead and jump into an example. Oops, removed too many pages. So here we have a binomial of 8xy minus, 8xy squared minus 5x cubed times y cubed times z. Let's go ahead and find the total degree of this binomial. Now we know this is a binomial because they have two terms. It is being separated by a minus. Again, we're adding a negative. So that's okay. So let's go ahead and see what the variables are. Variables are letters. So I have an x here and a y squared in the first term. I have an x cubed, y cubed, and a z in the second term. Now, a letter without an exponent does in fact have an exponent. That exponent just happens to be 1. Mathematicians are lazy, so we do not write it typically, but it is there. So let's calculate the total degree of each. So 8 is a number. 8 does not have an exponent, so we leave it out. X, I didn't write it, has an exponent of 1. Y has an exponent of 2. So for the first term, we have an exponent value of 3. The degree on the second term, we have x cubed, y cubed, and z to the first power. So adding all of them up, 3, 6, 7 is my exponential value. So for this binomial, it is a 7th degree binomial. Let's do one more here. We have a polynomial because we have 3 terms, so more than 2. We jump into poly. 3 is a number, so 3 squared, that's the same thing as saying 9. I don't have an exponent on 2 here, and I don't have an exponent on 8. I do have an exponent on 3. Excuse me, I do have an exponent of 3 on n, and I have an exponent of 1 on n here. So the only thing we are comparing is we are comparing a 3 for this one, and we are comparing a 1 for this one. So that means for this polynomial, we have a third degree polynomial. Just a brief introduction to monomials, binomials, polynomials. In the next video, we will be working with a little bit more examples of writing things in standard form and things like that. Thank you so much for watching. Take care.